Good morning. Today we have to see one more point, vibrations of air column. Vibrations of air column. One more point, that is vibrations of air column. दोन भाग आहेत. एक म्हणजेच vibrations of air column in a pipe open at one end and one more, that is in a pipe open at both ends. Second, that is in a pipe open at both ends. आता या दोघांचा फरक काय पाहता? In a pipe open at one end and in a pipe open at both ends. See. Vibrations of air column in a pipe open at one end. Diagram बघा. In this case, pipe is open at one end and closed at one end. Here, vibrations of air column in a pipe open at one end. एका बाजूला ओपन आहे, एका बाजूला क्लोज आहे. एका बाजूला ओपन, एका बाजूला क्लोज. When vibrating tuning fork, suppose this is vibrating tuning fork. When vibrating tuning fork is held at the mouth of pipe open at one end, then longitudinal waves produces which travels along a pipe towards closed end and gets reflected from closed end. These incident waves and reflected waves interfere with each other and stationary waves produces in that pipe. इथं पहा, जर पाईप एका बाजूला ओपन असेल तर हिथून लॉन्जिट्युडिनल वेव्स खाली जातात, हिथं रिफ्लेक्ट होऊन त्या या डायरेक्शन जातात. These incident waves and reflected waves interfere with each other and stationary waves produces. In this case, node is exactly found at closed end and antinode is found exactly at open end. म्हणजे खरं तर त्याची सिच्युएशन अशी तयार होत असते या पद्धतीनं. हिथं इथं नोड, तर इथं अँटीनोड. इथं नोड, इथं अँटीनोड. नोड, अँटीनोड, नोड, अँटीनोड. C. Vibrations of air column in a pipe open at one end. When vibrating tuning fork is held at the mouth open at one end, a pipe open at one end, then longitudinal waves travels along a pipe towards closed end and gets reflected from this closed end. These incident waves and reflected waves interfere with each other and stationary waves produced in the air column. There must be node at closed end and antinode is at open end. हे झालं पाईप ओपन ॲट वन एंड आणि ओपन ॲट बोथ एंड असेल तर त्याची सिच्युएशन अशी असते. ओपन ॲट बोथ एंड असेल तर त्याची सिच्युएशन ही अशी असते. Pipe open at both ends. When vibrating tuning fork is held at the mouth of pipe open at both ends, then longitudinal waves travels along a pipe towards other open end and gets reflected from that open end. These incident waves and reflected waves interfere with each other and stationary waves produces. See once more. When vibrating tuning fork is held at the mouth of pipe open at both ends, then longitudinal waves travels along a pipe towards other open end, gets reflected from that end. These incident waves and reflected waves interfere with each other and stationary process. In this case, antinodes are formed at both open ends. म्हणजे त्याची सिच्युएशन अशी तयार होत असते. Antinodes are formed at both open ends like this. Antinodes are formed at both open ends. हिथं अँटीनोड, हिथं मध्ये नोड, हिथं नोड, हिथं अँटीनोड, हिथं नोड, हिथं नोड, हिथं अँटीनोड, नोड, अँटीनोड, नोड, या पद्धतीचा हा त्या दोघांचा फरक आहे. आता बघा, vibrations of air column in a pipe open at one end. When vibrating tuning fork is held at the mouth of pipe open at one end, then longitudinal waves travels along a pipe towards closer end and gets reflected from closer end. Due to superposition of incident and reflected waves, stationary waves produces in that pipe. there must be node at closed end and antinode at open end. Let's suppose L, that is length of pipe, L, that is length of pipe. Then air column in pipe vibrates with different modes. First mode of vibration, second mode of vibration, and one more, that is third mode of vibration. Air column vibrate with different modes, first mode, second mode, third mode. If air column in a pipe open at one end vibrates such that only one node and only one antinode is formed, called as first mode of vibration. एकच नोड आणि एकच अँटीनोड असतो, ओनली वन नोड अँड ओनली वन अँटीनोड इज फॉर्म्ड. फॉर सेकंड मोड ऑफ व्हायब्रेशन, two nodes and two antinodes are formed. Means if air column in a pipe open at one end vibrates such that two nodes and first mode of vibration. What is first mode of vibration? If air column in a pipe, open at one end vibrates such that only one node and only one antinode is formed, called as first mode of vibration. What is first mode of vibration? If air column in a pipe open at one end vibrates such that only one node and only one antinode is formed, then it is called as first mode of vibration. Second mode, याच पद्धतीनं if air column in a pipe open at one end vibrates such that two nodes and two antinodes are formed, then it is called as second mode of vibration. Third mode of vibration, if air column in a pipe open at one end vibrates such that three nodes and three antinodes are formed, then it is called as third mode of vibration. Now, for first mode of vibration, node is formed at closed end and antinode is formed at open end. If suppose L, that is length of pipe, N1 frequency of first mode of vibration, lambda 1 wavelength of first mode of vibration, N1 frequency of first mode of vibration, lambda 1 wavelength of first mode of vibration, then लेंथ ऑफ पाइप, ही जी टोटल लेंथ आहे ती किती आहे, डिस्टन्स बिटवीन अँटीनोड अँड नोड, लेंथ ऑफ पाइप इज इक्वल टू डिस्टन्स बिटवीन नोड अँड अँटीनोड, and distance between node and antinode is lambda by 4, that is lambda by 4. This is for first mode of vibration, therefore lambda 1 by 4, and therefore lambda 1 is equal to 4 L. Now, velocity of wave, the frequency of first mode of vibration N1 is equal to V divided by lambda 1, and therefore frequency of first mode of vibration N1 is equal to V divided by 4 L. Suppose this is equation number 1. What is frequency of first mode of vibration? That is V divided by 4 L. This frequency is called as fundamental frequency or first harmonic. ही जी पहिली फ्रिक्वेन्सी आहे त्याला म्हणतात फंडामेंटल फ्रिक्वेन्सी और फर्स्ट हार्मोनिक. मग इथं जसं आपण केलं तसं आपल्याला सेकंड मोड आणि थर्ड मोडला करायचंय. काय काय केलं बघा. लेट N1 frequency of first mode of vibration, lambda 1 wavelength of first mode of vibration, then length of pipe. ही जी टोटल लेंथ आहे, टोटल लेंथ किती, distance between node and antinode, that is lambda by 4 and therefore lambda 1 is equal to मिळालेला लॅम्बडा आपण इथे ठेवतोय. This is frequency of first mode of vibration. This frequency is called as fundamental frequency or first harmonic. Now for second mode, two nodes and two antinodes are formed. If suppose N2, that is frequency of second mode of vibration, lambda 2, that is wavelength of second mode of vibration, then length of pipe L is equal to हिथून हितपर्यंत लॅम्बडा बाय 4, हिथून हितपर्यंत लॅम्बडा बाय 4, हिथून हितपर्यंत लॅम्बडा बाय 4, that is 3 times lambda by 4, and therefore which implies lambda 2 is equal to किती येईल 4L divided by 3, and therefore frequency of second mode of vibration N2 is equal to phi divided by lambda 2, which is equal to phi divided by 4L divided by 3, and therefore N2 is equal to 3 times phi divided by 4L. Suppose this is equation number 2. This is called as second harmonic or first overtone. Second harmonic, or it is also called as first overtone. Fundamental frequency is first harmonic. Fundamental frequency is first harmonic, and then second harmonic, third harmonic, fourth harmonic. फंडामेंटल फ्रिक्वेन्सी नंतर ओव्हरटोन सुरू होतात म्हणून ह्याला म्हणतात फर्स्ट ओव्हरटोन, सेकंड ओव्हरटोन, थर्ड ओव्हरटोन, लाईक दिस. दिस इज अबाउट second mode of vibration. Now third mode of vibration. If suppose N3, that is frequency of third mode of vibration, lambda 3 wavelength of third mode of vibration, then length of pipe is equal to हिथून हितपर्यंत 1 2 3 4 5 म्हणजेच 5 times lambda by 4, which implies wavelength of third mode of vibration 4 वरती जाईल 5 खाली, that is 4L divided by 5, and therefore frequency of third mode of vibration, that is phi divided by lambda 3, which is equal to phi divided by 4L by 5, and therefore N3 is equal to 5 times phi divided by 4L. This is frequency of third mode of vibration, that is third harmonic or second overtone. ह्याला म्हणतात फंडामेंटल फ्रिक्वेन्सी और फर्स्ट हार्मोनिक, सेकंड हार्मोनिक, थर्ड हार्मोनिक. फंडामेंटल फ्रिक्वेन्सी नंतर ओव्हरटोन सुरू होतात म्हणून ह्याला म्हणतात फर्स्ट ओव्हरटोन, सेकंड ओव्हरटोन, थर्ड ओव्हरटोन, लाईक दिस. आता हिथं पहा, हिथं 1 times phi divided by 3L 4L आहे, हिथं 3 times आहे, हिथं 5 times आहे, means 1 3 5, thus only odd harmonics are produces in a pipe open at one end, open at one end. म्हणजे जर समजा पाईप एका बाजूला ओपन असेल तर फक्त ऑड हार्मोनिक तयार होतात. प्रत्येक ठिकाणी इथं 3/4 आहे. फक्त इथं 1 times, 3 times, 5 times odd numbers आहेत, and therefore only odd harmonics are present in a pipe open at one end. In general, frequency of pith harmonic, frequency of pith overtone म्हणा किंवा pith harmonic म्हणा, that is 2p plus 1 into fundamental frequency. म्हणजे समजा सेकंड ओव्हरटोन काढायचं असेल तर डबल करून 1 न वाढवायचं. समजा सेकंड ओव्हरटोनची जर फ्रिक्वेन्सी काढायची असेल तर डबल करून 1 न वाढवा इंटू एन, या पद्धतीनं. दिस इज अबाउट व्हायब्रेशन्स ऑफ एअर कॉलम इन अ पाईप ओपन ॲट वन एंड. सिमिलरली व्हायब्रेशन ऑफ एअर कॉलम इन अ पाईप ओपन ॲट बोथ एंड. आता पाईप दोन्ही बाजूला ओपन आहे. Then antinodes are formed at both open ends. If vibrating tuning fork is held at the mouth of pipe open at both ends, then longitudinal waves propagates which travels through pipe along its length and gets reflected from open end. These incident waves and reflected waves interfere with each other and stationary waves process in that pipe. In this case, antinodes are formed at both open ends. दोन्ही बाजूला अँटिनोड तयार होतात. नेहमी लक्षात ठेवायचं, अँटिनोड हा ओपन एंडलाच तयार होत असतो. अँटिनोड्स आर फॉर्म्ड ॲट बोथ ओपन एंड्स. इथे देखील याला म्हणतात फर्स्ट मोड ऑफ व्हायब्रेशन, सेकंड मोड ऑफ व्हायब्रेशन, थर्ड मोड ऑफ व्हायब्रेशन. First mode of vibration, second mode of vibration, and third mode of vibration. In case of first mode of vibration, if air column in a pipe vibrates such that two antinodes and only one node, एकच नोड आहे पण antinodes फक्त डबल आहेत. If air column in a pipe vibrates such that only one node and two antinodes are formed. जसं आपण केलं तसंच पहा. If air column in a pipe open at both ends vibrates such that only one node and two antinodes are formed, then it is called as first mode of vibration. याच्या बाबतीमध्ये 2 nodes and 3 antinodes means if air column in a pipe vibrates such that 2 nodes and 3 antinodes are formed, then it is called as second mode of vibration. For third mode, if air column in a pipe open at both ends vibrates such that 3 nodes and 4 antinodes are formed, then it is called as third mode of vibration. इथं काय होतं, जेवढे नोड असतात त्यापेक्षा 1 न जास्त अँटिनोड असतो. जो मोड आहे तेवढेच नोड, त्याच्यापेक्षा 1 न जास्त अँटिनोड. बघा, जो मोड ऑफ व्हायब्रेशन आहे तेवढे नोड आणि त्याच्यापेक्षा 1 न जास्त अँटिनोड, या पद्धतीनं. ना what is first mode of vibration? If air column in a pipe open at both ends vibrates such that only one node and 2 antinodes are formed, then it is called as first mode of vibration. If suppose L, that is length of pipe, N1, that is frequency of first mode of vibration, λ1 wavelength of first mode of vibration, then length of pipe is equal to, ही लेंथ किती आहे, डिस्टन्स बिटवीन टू अँटीनोड्स, दॅट इज लॅम्बडा बाय 2. Distance between any two nodes or antinodes is lambda by 2, which implies wavelength of first mode of vibration lambda 1 is equal to 2L. हिथं अँटीनोड दोन अँटीनोड मधलं डिस्टन्स लॅम्बडा बाय 2, therefore lambda is equal to 2L means wavelength of first mode of vibration 2L, and therefore frequency of first mode of vibration phi divided by lambda 1, which is equal to phi divided by 2L. This is fundamental frequency of first harmonic. This is fundamental frequency or first harmonic. For second mode of vibration, two nodes and three antinodes are formed. Let's suppose N2 frequency of second mode of vibration, lambda 2 wavelength of second mode of vibration, then length of pipe is equal to 2 times lambda by 2. हिथून हिथपर्यंत लॅम्बडा बाय 2, डिस्टन्स बिटवीन टू अँटीनोड्स हिथून हिथपर्यंत लॅम्बडा बाय 2, हिथून हिथपर्यंत लॅम्बडा बाय 2, that is 2 times lambda by 2, which implies wavelength of second mode, that is 2L divided by 2. समजा ही व्हॅल्यू आपण फ्रिक्वेन्सी मध्ये ठेवली तर फ्रिक्वेन्सी ऑफ सेकंड मोड ऑफ व्हायब्रेशन phi divided by lambda 2, that is 2 times phi divided by 2L. हिथं 1 times phi divided by 2L, हिथं 2 times phi divided by 2L. तसं आता हिथं फॉर थर्ड मोड ऑफ व्हायब्रेशन 3 nodes and 4 antinodes are formed. हिथून हिथपर्यंत 1, हिथून हिथपर्यंत 2, हिथून हिथपर्यंत 3 means 3 times distance between two antinodes. Let N3 frequency of third mode of vibration, lambda 3 wavelength of third mode of vibration, then length of pipe is equal to 3 times lambda by 2, which implies lambda is equal to 2L divided by 3. इथं फार लॅम्बडा 3 घेऊया आपण, and therefore frequency of third mode of vibration, that is 3 times L divided by 2L. Suppose this is our equation number 3. This is our equation number 2. ह्याला म्हणतात फंडामेंटल फ्रिक्वेन्सी और फर्स्ट हार्मोनिक. फर्स्ट फ्रिक्वेन्सी इज कॉल्ड एज fundamental frequency or it is also called as first harmonic. ह्याला म्हणतात second harmonic or it is also called as first overtone. ह्याला म्हणतात third harmonic or second overtone. First frequency fundamental frequency, second frequency that is has a first harmonic, second harmonic is first overtone, third harmonic is second overtone, like this. याचा अर्थ काय मग हार्मोनिक्स आणि ओव्हरटोन मध्ये काय फरक आहे. हार्मोनिक अँड ओव्हरटोन आपण काय करू, ह्या दोघांचा डिस्टिंग्विश पहिला पाहूया. डिस्टिंग्विश बिटवीन हार्मोनिक्स अँड ओव्हरटोन्स. हार्मोनिक आणि ओव्हरटोन. डिस्टिंग्विश बिटवीन हार्मोनिक अँड ओव्हरटोन. फर्स्ट, frequencies which are integral multiple of fundamental frequencies. The frequencies which are integral multiple of fundamental frequencies. म्हणजे fundamental frequency are 2 times, 3 times, 4 times. The frequencies which are integral multiple of fundamental frequencies are called as harmonics. And frequencies other than fundamental frequencies or above fundamental frequencies are called as overtones. Fundamental frequency is not overtone. Fundamental frequency पुढे overtone असतात. Means frequencies other than fundamental frequencies are called as overtone. बघा दोघांचा आपण डिस्टिंग्विश पाहतोय. The frequencies which are integral multiple of fundamental frequencies are called as harmonics, and the frequencies other than fundamental frequencies are called as overtones. Second, all harmonics are not overtones, but all overtones are harmonics. सर्वच्या सर्व ओव्हरटोन हार्मोनिक असतात, पण सर्वच्या सर्व हार्मोनिक ओव्हरटोन असतात. फर्स्ट हार्मोनिक इज नॉट ओव्हरटोन. फंडामेंटल फ्रिक्वेन्सी और फर्स्ट हार्मोनिक इज नॉट ओव्हरटोन. Then one more, that is first harmonic is same as fundamental frequency. First harmonic is same as fundamental frequency. First overtone is next higher fundamental frequency. Fourth, harmonics are integral multiple of frequency. Overtone are not integral multiple of frequency. इथं इंटिग्रल मल्टिपल मध्ये येतात, इथं इंटिग्रल मल्टिपल मध्ये येत नाहीत. दीज आर सम डिस्टिंग्विश बिटवीन हार्मोनिक्स अँड ओव्हरटोन्स. काय काय सांगितलं? The frequencies which are integral multiple of fundamental frequency is called as harmonic, and the frequency other than fundamental frequency is called as overtone. All harmonics are not overtone, but all overtones are harmonic. First harmonic is a fundamental frequency, and first overtone is next higher frequency, fundamental frequency or first harmonic. Harmonics are integral multiple of fundamental frequency, but overtones are not integral multiple of fundamental frequency. यामध्ये आपल्याला आणखी एक टर्म पाहायची आहे, ती म्हणजेच अबाउट एंड करेक्शन. एंड करेक्शन. आता ही काय टर्म आहे बघा. अबाउट एंड करेक्शन. In a pipe closed at one end, antinode is not exactly found at open end. In a pipe closed at one end, खरं तर अँटीनोड हितच निर्माण व्हायला पाहिजे, पण तो हित निर्माण न होता तो हित थोडासा वरती तयार होत असतो. खरं तर अँटीनोड हित निर्माण व्हायला पाहिजे, पण तो हित निर्माण होतो. इन अ पाइप क्लोज्ड ॲट वन एंड, antinode is not exactly found at open end but little distance above it due to free air at open end. म्हणजे याच्या कंपॅरेटिव्हली या ठिकाणची एअर फ्री असते, त्यामुळे अँटीनोड हित चालतो. हे जे लेंथचं करेक्शन आहे, दिस करेक्शन इज कॉल्ड एज एंड करेक्शन. व्हॉट इज एंड करेक्शन? At resonance, node is formed at closed end. Node is formed at closed end and antinode is formed at open end. But antinode is not exactly found at open end, but a little distance beyond it. This distance is called as incursion. This is because air is more free to vibrate. Air is more free to vibrate at open end. म्हणजे ओपन एंडला एअर ही मोर फ्रीली व्हायब्रेट होत असते. तर बघा काय सांगितलं, व्हॉट इज इनकर्शन, व्हॉट इज इनकर्शन at resonance node is formed at closed end and antinode is formed at open end, but antinode is not formed exactly at open end but a little distance beyond it. That correction in length is called as incursion. This is because air at open end vibrates more freely than air at closed end, and therefore antinode is formed a little distance beyond it. That correction is called as incursion. If suppose D, that is inner diameter of pipe, then end correction E is equal to 0.3 D. हा एंड करेक्शन काढण्याचा फॉर्म्युला आहे. व्हॉट इज एंड करेक्शन, व्हॉट इज एंड करेक्शन, दॅट इज 0.3 D, where D is inner diameter and therefore actually length is equal to, समजा इथून इथपर्यंतची लेंथ आहे L1 आपण मेजर केली, त्यामध्ये हा एंड करेक्शन that is L1 plus E, which is equal to L1 plus 0.3 D. By using formula, actually length of vibrating point can be determined. पाईप एका बाजूला ओपन असेल तर एकाच बाजूला इनकरेशन तयार होतो, आणि जर पाईप दोन्ही बाजूला ओपन असेल तर दोन्ही बाजूला इनकरेशन तयार होत असतो. For a pipe open at both ends, actual length is L1 plus 2 times E. पाईप एका बाजूला ओपन असेल तर एकाच ठिकाणी इनकरेशन तयार होतो, पण जर पाईप दोन्ही बाजूला ओपन असेल तर हिथं पण इनकरेशन तयार होतो आणि हिथं पण इनकरेशन तयार होतो, आणि म्हणून ऍक्च्युअल लेंथ घेत असताना हिथं 2E करायचं, म्हणजे दोन्ही बाजूचा इनकरेशन त्यामध्ये ऍड करायचं. This is about end correction. काय सांगितलं तुम्हाला डेफिनेशन, व्हॉट इज end correction? At resonance node is formed at closed end and antinode is formed at open end, but antinode is not exactly formed at open end but a little distance beyond it. That correction in length is called as incursion. This is because air at free end vibrates more freely as comparatively air vibrates at closed end. Okay. If D is inner diameter of tube, then incursion is equal to 0.3 D. D ला म्हणतात inner diameter. जर पाईप एकाच बाजूला ओपन असेल तर इनकरेशन हा एकच तयार होत असतो एकाच बाजूला. पाईप दोन्ही बाजूला ओपन असेल तर मग दोन्ही बाजूला इनकरेशन तयार होतो, मग त्या व्हायब्रेटिंग लेंथ मध्ये 2E ऍड करायचा. दिस इज अबाउट इनकरेशन. ओके, रिमेनिंग पार्ट ऑफ नेक्स्ट पिरियड.